Hello everyone, my name is Ehsan Mahmood. I am third year BTech computer science student from Bennett University. In today's video, I am going to explain the topic I choose to present in my seminar subject, that is fiber optics. On today's video, first I will give brief description of fiber optics, then advantages of fiber optics, after that communication with fiber optics construction, and principle of operations like total internal reflection, dispersion and all. Then modes and materials of fiber optics, losses and fiber optics cables, applications of fiber optics and conclusion. What comes to your mind when you heard about fiber optics? We know that fiber optics is the technology used for transmitting information as pulse of light through strands of fiber made of glass or plastic over long distances. On the other hand, an optical fiber is essentially a waveguide for light. It consists of a core and cladding that surrounds the core, where the index of refraction of the cladding is less than that of the core, which causes the ray of light to leave the core to be refracted back into the core. Now let's talk about advantages of fiber optics. There are many advantages of fiber optics. Some of the advantages are: it has greater bandwidth than copper. The loss in case of fiber optics is lower. Immunity to crosstalk, and it has no electrical hazard. Now let's discuss about fiber optics and communication system. In communication process of fiber optics, it transmits a signal in the form of light, which is first converted into the light from electrical signals, and then it transmitted. And then vice versa happens on the receiving side. We can also get a clear idea from the image given in the right side. Fiber optics construction. Fiber optics is made from thin strands of either glass or plastic, as it has little mechanical strength, so it must be enclosed in a protective jacket. Often two or more fibers are used to increase bandwidth and redundancy in case one of the fibers breaks. It is also easier to build a full duplex system using two fibers, one for transmission in each direction. Now I will be talking about principal operations of fiber optics. Total internal reflection. Fiber optics works on the principle of total internal reflection. As we can see in figure C, when the angle of incident is greater than the critical angle, then the ray of incident is reflected back to the medium. The phenomenon is known as total internal reflection. The angle of refraction at the interface between two medium is governed by Snell's law, which is n1 sin theta 1 equal to n2 sin theta 2, where n1 and n2 are the refractive index of medium, and theta 1 is the angle of incident and theta 2 is the angle of refraction. Fiber optics also use the principle of numerical aperture. The numerical aperture of the fiber optics is closely related to the critical angle and is often used in the specification for optical fiber and the component that works with it. Now let's discuss about modes and materials of fiber optics. Since optical fiber is a waveguide, light can propagate in a number of modes. If a fiber is of large diameter, light entering at different angles will excite different modes, while narrow fiber may only excite one mode. Multimode propagation will cause dispersion, which results in the spreading of pulses and limits the usable of bandwidth. Single-mode fiber has much less dispersion, but more expensive to produce. It is small size together with the fact that its numerical aperture is smaller than that of multimode fiber, which makes it more difficult to couple to light sources. Dispersion. Dispersion in fiber optics results from the fact that in multimode propagation, the signal travels faster in some mode than it would in others. Dispersion increases with the bandwidth of the light source. Now let's discuss about the losses in fiber optics. Losses in fiber optics results from attenuation in the material itself and from scattering, which causes some light to strike the cladding at less than the critical angle. If we bend the optical fiber too sharply, it can also causes loss by causing some of the light to meet the cladding at less than the critical angle. Now let's discuss about the optical cable construction. There are two types of fiber optic cable as we can see in the image. One is loose tube cables and the other one is tight buffer cable. Loose tube cables are specially designed for harsh environments. They protect the fiber core, cladding, and coating by enclosing everything with semi-rigid protective sleeves or tubes. The water-resistant gel helps fiber from moisture, making the cable ideal for harsh environment where water or condensation can be problem. On the other hand, tight buffer cables are optimized for indoor applications because they are sturdier than loose tube cables. They are best suited for moderate length LAN or WAN connection. We can also use tight buffer cable for underwater application. The advantages of both the cables are the fiber in loose tube cables are free to expand and contract with the temperature. On the other hand, tight buffer cables are cheaper and generally easier to use. Now let's discuss about the applications of fiber optics. Optical fiber communication is mainly used in the telecommunication industry, which uses the optical fiber for telephone signal transmission, internet communication, cable television signal transmission. Apart from it, fiber optics nowadays is used everywhere in home, industries, office for long distance as well as for small distance communication. We know that optical fiber technology has been used in many areas such as telecommunication, medical, and engineering. It has attracted many researchers due to its performance, lower losses, no interface, higher bandwidth, and its inherently higher data carrying capacity. Although optical fiber have many advantages, there still exist some disadvantages. One of the disadvantages of fiber optics is that, in spite of the natural abundance of the material for optical fiber construction, which is the sand, the fibers are more expensive compared to copper. With this, now I am going to conclude the video. Thank you for listening. If you have any questions and queries, please write it in the comment section.